Now we have these three steps here: the raw data, the data without the background, normalized data. In the normalized data, you see that I added norm to the name of the graph and also changed the name of the y-axis to normalized Raman intensity that changed now from 0 to 1.0. Here you can see that there are some differences here in the intensity that can attribute to the differences in the background. There are also some differences in the width of this peak. And sometimes we would be interested to see how much the spectra vary from point to point. But if we are not, and we just want to improve the quality of the data by reducing the noise and not interested in the discrepancies between the points, we can average them. To do that, you can copy all the data you want to average in one workbook. By creating the new book, I'm now going to copy the x-axis that is going to be common for all of them and the y-axis that I want to see. For example, the normalized data for the P1. I'm going to add a new column for each of the plots that we will average. The P2, P3, and P4. Copy, paste. Now I'm adding the new column and I'm going to set the values of this column. Right click here and set column values. Here I can input most of the basic mathematical functions of interest. So I'm going simply to make the sum of the 4 columns with the normal data divided by 4. Apply. Here you have now the new set of data. And I can create a new plot for that, but I can also add this to the plot with the normalized data for comparison. Take a look here. I go to this plot and I'm gonna right click and add layer contents, and the new book, it appears here now, and I have the average data that I'm going to add. Okay, now what I still need to do is to reformat it all a bit so that you could see the differences. I have made now the original data thin by line, and I'm gonna set that the color shouldn't change. So the color is going to be gray. And you can see now very clear differences between the average data, where the noise level is much lower, and the raw data, where the noise level is much higher.